video we're going to be introducing the Poisson distribution. We use the Poisson distribution when there are a certain number per something. The keyword here is per. For example, the number of calls to a call center per hour, or the number of worms per meter squared of grass. And we're given these formulas here on the formula sheet. So let's have a quick look at what the letters in here mean. The first letter here is this. This is the Greek letter lambda, and this is always our mean. And we obviously already know x is the particular number that we're after, and e is a mathematical constant that's approximately equal to 2.71828, and it just keeps going on forever and ever, kind of the same way that pi does. So we're going to look at several things in the following videos, but there are a couple of assumptions that this distribution makes. It assumes that the occurrence of whatever it is we're looking at is random and independent from the other occurrences. But the big assumption is that the number of items or events is proportional to the area or the time, etc. It also assumes that the items or events cannot occur at exactly the same time or in exactly the same space. For example, two worms can't be occupying the same space in an area of grass, and two calls can't happen to a call center at exactly the same time. They might happen exactly the same millisecond, but if you keep cutting that time in half and half and half and half and half again infinitely, they won't happen at exactly the same time. But the big thing you need to remember is if you can reword the question so it is something per something, for example, the amount of goody goody gumdrops per litre of ice cream, then we're going to be using a Poisson distribution. Just as a quick side note, Poisson might be French for fish, but it doesn't actually have anything to do with fish. It was invented by Mr. Poisson.